Hello there, this is Chica Paris bringing you part 2 of how to make Flappy Bird, but it looks and feels exactly like Flappy Bird. So in the last tutorial, we made the foundations of Flappy Bird. In this tutorial, we will finally make the feels of Flappy Bird, or as they call it, the game juice. Now, if you haven't watched the previous tutorial, I do suggest that you watch that first, as this is a continuation of that. Now, fair warning, this tutorial is going to be a lot more difficult than the previous tutorial. But don't worry, as I will be trying to work on the easy parts first, and we'll just ramp up the difficulty as we continue on. So, let's begin. So, just a short recap of where we are right now in the game. We have made all the pipes, the bird, and the gravity, and the ground, and the collisions for both the ground and the pipe. So if we die, you could see we also have a death state. So the first thing we're going to be doing is that we're going to be changing the background so then there can be night and day, and the object bird can also be changing its color from red, yellow, or blue. So to do that, we're just going to go above this for loop and just going to say draw sprite, and then here in the sprite, remember that we have a parameters sprite, some image x and y. So the sprite will be bg, and then the subimage will become 0, and then the x and y will be 0 and 0. Now, if we run this game now, it will look exactly the same, as you could see. But if we were to change the sub-image to 1 and we were to run the game, we would see now that it is nighttime. Now, the reason why this is the case is because if we go to sprites and we go to the background here, the BG, we would see that the first sub-image 0 is daytime and sub-image 1 is nighttime. So basically, right now we're just switching in between the two. Now we want to be randomizing this. So if we go to the create event, we can create a new variable, and we're just going to call this bg sub. And this bg sub is going to be our irandom, which means it's going to be a random integer from 0 to 1, as you can see. And we just copy and paste this here. And if we run the game, this should give us, right now it's daytime, but if I click on the Q, it's going to be randomizing to either day or nighttime, depending on what the random value is. So right there, we already have random day and random night. Now, the next thing we want to be doing is that we want to be randomizing the color of the bird. Now, unfortunately, for the bird, it's not as simple as this background where it says we just change the sub-image. This is because there are SPR bluebird, SPR redbird, and SPR yellowbird. Each one of these sprites have their own sub-images per color. So to do that, we're just going to be making an array that's going to define what's bluebird, redbird, and yellowbird, as I'm going to be showing you right now. So we just go to the create, and we're just going to be creating this new variable under an array called bird call, and it's going to be making an array. So inside this array, we're going to just putting the SPR bluebird, and then we're going to say SPR redbird and SPR yellowbird. And then the sprite index is going to be equals to bird call, and then inside here is going to be irandom, a value from 0 to 2, because there are 3 colors, 0, 1, and 2. So if we run the game, now we can see that the color of the bird is blue. If we randomize this, it becomes red, and sometimes it's going to be yellow, and then blue, red, yellow. So we could see now we have randomized colors for the bird and randomized day and nighttime. So our next task is to add sound effects. So to do that, we're just going to be first setting up how loud the sound sounds like. So we're going to be doing this audio set master gain to 0.1. The reason why we're doing this is because if we were to go to sounds, and if I were to play this hit sound right now, they're going to be really loud. Yeah, so we want that to be 1/10 of the loudness. Next, we're going to go to our scripts or bird scripts, and every time we die, we're going to be playing that SFX hit sound. Every time we go to the dead state right here, we're going to say audio, play, sound, and here the sound will be SFX hit, and we're going to be putting priority 0, and the loop is going to be 0. We also want to be playing the sound when we go and touch the ground, which is in this point here. So just put that audio play sound effects hit. And if we were to run the game, now every time we hit the ground, we hear that death sound. If we go to the pipe, you'll also hear that death sound. Now another thing that we want to be hearing is that falling sound that if we hit the pipe. So we're just going to be adding this thing here, and we're going to add SFX die. Now this one will create that boo sound, but it's a little bit too early, so we need to be adjusting that. Now we'll try to get back to that delay sound later, but for now we're just going to be focusing on trying to add the other sound as well. So what other sounds do we want to be adding? We want to be adding every time we get the points. So we're going to be adding that coin sound. So we're going to say SFX points. And then another one that we want to be doing is that when we're flapping the bird. So when do we exactly flap? It's here, the is jumping. So we're going to be adding another sound effect here. And this one's going to be SFX wing. Now we could hear that famous sound, and when we go through the pipe we could hear the coin sound. Now while we try to add the fall delay sound, let's also add the flash of light that happens every time we die when we hit the ground or when we hit the pipe. So to do that, let's just go to object bird, and when we go to the draw event, then right here in the bottom we're just going to be adding this new function here, which will draw this SPR pixel at subimage 0, xy 0, 0, and then the x scale, y scale is 144 to 156, and then rotation 0, color C white, and then the alpha is flash. Now if we go down, we'll see that the SPR pixel looks like this. It's just a single tiny white pixel. We're just going to be drawing that white pixel, and we're just going to scale it to 144 by 256, which is the size of the room. This is why we're going to x scale and y scale this. And then this flash, this is a variable that we haven't yet made so far, so we're just going to be creating that. So we just put it here underneath. We say flash is going to be equals to, let's say, 1. So if we run this game, we should see that the entire room is just going to be white. So what we're going to do is that in the step event, we're just going to say that flash is going to be equals to maximum flash minus 0.05 or 0. So what this does is that when flash is 1, it's going to start decreasing it by 0.05, and then once it's 0, it will just remain 0 as the minimum value. So if we run this game, we should see it will start white and then it will turn like so. So we want to start this flash at value 0, and then when we die, so we go back to the bird scripts, we are going to be setting this thing to 1. Now right now it kind of looks like we're just repeating the function, so we're just going to be making a new function called die. And so this die function, we're just going to be putting it up here. We're going to declare it here. We're just going to say function die, and we're just going to be putting things that happens whenever we die. So what happens when we die? We're going to be copying all these, paste it here. Aside from this, we're going to be saying that flash is going to be equals to 1. We're just going to be copying this die function. We're going to be putting it here. There we go. So once we run the game, you see that when we hit the ground, a flash of light happens. And then when we hit the pipe, there's also that flash of light happens. Now we want it that when the flash of light is a little bit dimmer, that's when we run the falling audio. So when we die, this flash of 1, and then once we're in the dead state, which is down here, we're going to be asking ourselves if flash is equal to 0.1, and if y is less than 196, which means it's above the ground, that means we're going to be playing this audio sound. Instead of this SFX point, we're going to be playing SFX die. And if we're going to run this game, it should work according to plan. So if we hit the ground, since we were on the ground, it will just only play the death sound. But if we are going to be going to the pipe, it's going to also play the fall sound. Now currently we only have 2 states, the main state and the dead state. We want to be adding a third state, which is the beginning state or the preparation state. This state is when the bird will just be flapping in midair without you tapping the screen, and then the pipes are not yet moving. Only when we press on the screen do we go to the main state, and that's the time the pipe will start coming. So to do that, we're going to be going to bird scripts, and in the bird scripts we're going to be adding a new state. So we have dead state, main state. We're going to be adding a new state, and we're going to call this the prep state. Now here in the prep state, we are going to just make the bird stay in place. However, if we look at the original Flappy Bird, the bird is actually going up and down in a sinusoidal pattern. So we will be adding this line of code, which basically says that y is equals to y start plus a sine wave times 2. So basically this y start is the original y position of the object bird, which is right now at 128, plus this. Now, if you know what a sine wave does, it basically goes from 1 to -1. Inside this, the x value of the sine is current time times 0.08. So this tells us the interval time of how fast this sine wave goes up and down. And then this multiplied by 2 is giving us the amplitude of that sine wave. So right now, we're saying times 2, which means that the sine wave will go plus and minus 2 pixels. And then the middle point, the average, is the y start. So before we run this, we will go to object bird and we will go change the state. Instead of main state, we're going to change this to prep state. Now, if we run this, we would see that we are now in prep state and the bird is now flapping up and down in a sinusoidal pattern. Now, what we want to do is that once we tap on the screen, we want to be changing from the prep state to the main state, and then that's when all the pipes will start moving. Also, we could see that the ground is not yet moving. We want the ground to be moving already, so that it looks like the Flappy Bird is already flying. We're just not controlling it yet. So to do that, let's go back to bird scripts, and we're going to be adding the ground move first. We already have this. It's this code here. Since we are going to be duplicating the code instead of just copying and pasting it, we are going to be adding a new function called move ground. Now this move ground, we're going to be adding a function. Let's say it's up here. Function move ground. And in this move ground, we're just going to be pasting whatever we added. And so this move ground will also be part of the prep state over here. And then when we click on the screen, which is basically is jumping, we do this. So we're just going to copy this again too. And we're also going to be putting it here, function jump. So here we have the jump function jump. I'm just going to copy this function jump and paste it here in the main state. And also we're going to be adding it here in the prep state. Now we're also going to be asking ourselves, this is going to be returning is jumping. So we're going to say return is jumping. And once it returns is jumping, this statement here in prep state is going to ask if jump. So if the jump is true, then we are going to be changing the state to main state. Right now, we are doing everything. The ground is now moving. And then when we hit the screen, it's now to the main state. And now the pipes are moving. So the next thing we want to do is that we want to go and add this get ready and also this tap right so. So it's going to be looking something like this. And the position will be at 7288. And this position will be at 72,136. Now, just like the pipes and the ground, we are going to be drawing it in object bird instead of just putting it here directly in the game. So we're going to delete this, and then we're going to go to object bird. We'll go to the draw event. Just going to copy this guy here, and we'll paste it twice. And then we're going to say SPR get ready, and the other one is going to be SPR tap. So everything's the same except for this time, this flash, we just set it to 1. And then the size of this thing will be 1, 1, 1, 1. And then the XY coordinate, this one will be 72 and 88. And then the other one here, this will be also 72. And this will be 136. We would see that the get ready and the tap button will be there. But it's still there when we go to the main state. So when we go to the main state, this should fade out. And then once we restart the game, this should fade in. Now we could do the same thing with this white flash that we made earlier, but this white flash only fades out. We want this thing to do both fade in and fade out. To do that, we're going to be adding this new script, which I like to call lintrans. So this is going to be a function called lintrans, basically it's linear transformation. This one goes from one state to the other in a linear progression. So we have the source, the destination. So if we're going to be fading in, the source will be 0, destination will be 1, and an increment, this will be, let's say, 0.1, which means that for every frame, we're adding 0.1 until it reaches our destination. Now, the reason why it looks like this is because for the var sign, this tells us whether or not our destination is positive or negative relative to the source. So if it's positive, it's going to give us sign positive, which is going to be 1. If it's negative, it's going to give us negative 1. And then here, this clamp function, basically it clamps this value here in between the minimum and maximum value set. So it's going to be, if this is the value, it's only going to be somewhere in between the minimum and the maximum, somewhere in this region. If it goes beyond the maximum, it'll be clipped to the maximum. If it goes below the minimum, it'll be clipped to the minimum. So this is what this clamp function does. And basically, we get the source and then we increment it based on the sign. So if it's negative, we minus. If it's positive, we add this increment. And then we take the minimum of the source and destination and the maximum of the source and destination, whichever is bigger or smaller. So this is what this linear transformation does. Now we're going to be using this function, and we're going to be going back to object bird. Here, we're going to be adding a new function, and we're going to be calling this getReady. And this getReady is going to be just like the flash. So we're going to go here and say here, getReady is going to be equal to 0, just like the flash. Now in the step event, we are going to be saying, right underneath the flash, we're going to say that getReady is going to be equals to lin trans, and this function here, the source will be the getReady, the destination will be equals to if state is going to be equals to prep state, and if it is, then this is going to be equals to 1. If it's not, it's going to be equal to 0. And then the increment is going to be 0.05. So if we run this game, we would see that we now have transition. So when we begin, you could see the getReady fades in, and then once we get out, it fades out. Now, one of the most obvious features of Flappy Bird is its tilt every time you flap. So when it's going upwards, it's tilting up, and then once it starts falling, it starts tilting downwards all the way to -90 degrees. So how do we do that? Basically, we're just going to go to bird scripts, and we're going to be making a new function. The reason why we're making a new function is because this function will be applied to both the main state and the dead state. We will say function tilt is going to be equals to this, and then we say image angle is equals to clamp, and then here in the clamp we're going to again put image angle, and here we're going to say minus VSPD, and then the minimum angle is going to be -90, and then the maximum is going to be 20. And then we're just going to be copying this tilt function, and we're going to be adding it to the dead state and the main state here. Now that we're flapping, you could see now it's tilting, but it feels a little bit too slow. So we're going to be fixing that by adding some kind of multiplier to the tilt. So we're going to go to this VSPD, and then we multiply this by, let's say, 2. It still feels a little bit too slow. So we're going to be adding 4. Now this one seems like it for the positive, but it actually seems a little bit too fast once it goes to once it starts falling down. So what we're going to do is that we're going to be making it varied. How to do that is that we're going to ask if VSPD is greater than 0, which means that it is falling, then we're going to be changing this value here to something else. So we're going to say var, we're going to be making a local variable, and we're going to say multiplier or mul is going to be equals to 4. And then if it's greater than 0, we're going to say that mul is going to be equals to 2. And then we're just going to copy this mul, and we're going to pasting it here, multiply by this value here. And there we go. Now we got something that looks very similar to the Flappy Bird's tilting movement. So if you didn't really understand how tilt works, basically we have this image angle, and this is going to be changed to this new value here, which is based on the VSPD. So if the VSPD is going upwards, it's going to make this angle increased. If it's going downwards, it's going to decrease that angle. Now this angle is clipped to -90 and 20. -90 is pointing downwards, while 20 is pointing slightly up. Now I've noticed that when the bird goes to the ground, it's a little bit planted too far in the ground, and that's because our value 196 here is actually wrong. It's supposed to be 194. So this is where it gets a little bit dumb to actually just put the value straight directly in your scripts instead of saving it into a variable. So we're going to be changing that and having good practice, we're going to be saying that this 196 is going to be the ground level. And this ground level is going to be a variable that we're going to be propagating. So we're just going to be finding all the 196. So that's 196 here. And then we can find another 196 down here. And we can find another 196 down here. So there we go. We just found all the 196. And we just go back to object bird. And we're going to be going to variable definitions. And we're going to be adding a variable name called ground level. And we're going to be setting this to 194, not 196. So when we run the game, we would see that the bird is now a little bit above the ground when it dies, not too far in. Aside from ground level, we can also make variables for the start of the pipe X and its interval. So we can say pipe X start is going to be equals to 300, which is this value here. And then we have this 80, which is the interval. So we're going to say pipe X interval is going to be equals to 80. So we're just going to copy this and paste this here to the 80. And this also is here as well. Now, that's the reason why we want to be adding this pipe X intervals, because let's say we want to be changing the pipe X interval to, let's say, something even more frequent, let's say 40. And when we run the game, we would see that the pipes are now coming in more frequently, which is nice. We also want to be adding more pipes. Let's say since we have 40, we need to have more pipes instead of just 3. So we can actually do that as well. We can add pipe num. And let's say we set this now to 6 because last time it was 3, now it's 6. So we go to this one here and we just set this one pipe num -1. And we can go to the bird scripts and we can set this here to pipe num. There we go. And we can also, let's just say, instead of 300, let's say we want to make it really quick. We want to say set it to 100 so it comes in a lot quicker than before. It's already there. There we go. It's a lot quicker now. And one last thing which we forgot to fix is this 3 here. This should also be equals to pipe num. And this one should be equals to pipe num -1. And then last but not least, we go to the draw event. And we change this drawing here to pipe num. And so, when we play the game, we would see that the pipes are all coming in like so. This is going to be a lot more challenging. Oh my god. Of course, because we're trying to faithfully remake Flappy Bird, we need to be reverting these variables back to its original. So this one will become 300, this one becomes 80, and this one becomes 3. And so if you run the game, it should look exactly the way it looked like before. So that is the benefit of having the variables just ready right there instead of directly changing it in the script. Because by doing so, we can just change the variables and everything will change and it will look exactly the same. And I'm actually speaking while playing at the same time, which is actually very cool of me. Holy, yeah, look at that. Look at that, we're already in 15 points. Let's see how far we can go actually. I'm going to get distracted here. I'm still going. And I'm going to tell you that I'm not cheating. If you saw me cheating, I don't know. As a game developer tip, you want to make your game feel like you have good luck. So when you hit something but you're given the chance not to be, that you're given an extra, whatever. I'm actually blabbering right now, but that's okay because I'm basically just keeping going on and we're about to reach 69. Let's look, 68. Nice. Oh, there we go. So we actually could die and we've reached 71. That's a long video. So as we add more and more features to our Flappy Bird, it's starting to look and feel exactly like Flappy Bird. But there are some glaring problems that we still could see. And right now there's one big one, and that's the score. We need to fix that. So normally we let the game engine handle the text drawing, which makes it really easy for us to just type whatever we want to type and it's just going to print that text onto the screen. But we're going to be doing this manually. Now here are the problems. We are drawing the score right in the middle of the screen, which means that as we add more digits, the leftmost digit starts going more and more towards the left and the rightmost digit goes more and more to the right. So it's starting to grow like so. Another problem is that these digits don't have the same width. Well, for the 2, 3, 4, 5, 6, 7, 8, 9, they do. But for the 1, which is over here, I don't know why it's over there, it's a lot smaller. And so we have to account for that as well. Another problem, which is specifically for these digits in Flappy Bird, is that there is a shadow on the lower left corner of each of these digits, which means that if we're going to be drawing 6 and 7, let's say we draw 6 first, then 7, it will look something like this, which is fine because the shadow is underneath the 2 digits. But if we draw the 7 first, then the 6, what's going to happen is that this shadow is going to go over the 7 and it's going to look funny because you could see that there's this little dark part here and it doesn't look that good. Now trying to find out how to print this manually is pretty difficult, and I found it pretty difficult. This is actually the most difficult part for me. Fortunately for you guys, I already know how to do it, and so I'm just going to be copying and pasting a code and I'll just be explaining what that code does. So we just go to Object Bird and then we're going to the draw event, and then here in the draw we're just going to add a new function over here and we're just going to put this function. So as you can see, it's a pretty long function and I'll be explaining each part one by one. So the first part are these 3 local variables. The n orig will be equals to this n, which is your score. So it's going to store the original score as we're going to be altering this n value later on. Next are the digits and the width. The digits is the number of digits there are in your score, and the width is the pixel width of your score. Right now they are set to 0 as we are initializing these variables, but later on we are going to be getting the digits and the width, and we're going to be getting it through this while loop. So what's going to happen is that this while loop is going to ask, is this n greater than 0? So while this is greater than 0, it's going to start looking at each digit. So this statement here basically is asking for the rightmost digit, n modulo 10. And it's asking, is it equals to 1? If it's equals to 1, we give a width of 6, else we give a width of 10. The reason why we're doing this is because 1 is a special case. 1 is the only one with a width of 6, while all the other digits have a width of 10. Also, I forgot to mention these digits. Every time we go through the while loop, we are adding digits plus plus. We're incrementing the digits. So as we see one digit, we increment the digit, and then we just keep on doing that until we ran out of digits. Now, this n value changes here. So what's happening is that we are dividing this. This div is not the same as the division or the slash, as this one is integer division. Basically, this n divided by 10 will just remove the rightmost digit from the n until n becomes 0 or less. Now, how exactly did we get this 6 and 10? If we go to our big number sprite here and we let's say click edit, if we go to 1, you would see that this is going to be 1, 2, 3, 4, 5, 6. So 6 is here. Why is it not 7? Well, that's because this line here is going to be overlapping with the next digit. So that's why we don't count that. If we go to let's say 0, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the same thing, we don't count this part here as this is going to be overlapping with the next digit to the right. So we add all the widths together, and so we get the total width, and then here we're going to be asking for this edge case, which is when n is equal to 0, because this while loop will not work if n is equal to 0. It's just going to skip this. So if it is equal to 0, we're going to say the width is 10 because 0 has a width of 10, and we're going to say digits is equal to 1 because writing 0 is 1 digit. So the next step is that we're going to be finding where we are going to start drawing our text. So that is the x value here. So this x value is equal to 72 minus width times 0.5. What does this mean? Well, this 72 came from the width of the room, which is 144. So when you say 72, that's basically half of 144. So that means that's the x coordinate at the middle of the room. And then this width times 0.5 basically means from the center of the room, which is 72, we are going to be drawing the text minus width times 0.5, which means that we're actually going to make the center of the text at the center of the room as well, because half of the text is going to be to the left of the center, while the other half will be to the right of the center. So now that you have taken care of the width and where to draw the first digit, let's actually start drawing the digits. So remember, we are drawing the leftmost digit, not the rightmost digit. And when we did this while loop here, we were accessing the rightmost digit first. We want to be accessing the leftmost digit first. So how do we do that? Well, we are using this for loop here, which is actually decrementing, as you could see, I minus minus, and we start from digits minus 1. That's because we want to be starting from the leftmost digit. Now, what this line here does is that it gets the leftmost digit. How does it work? Well, basically, let's say, for example, we have numbers 1, 2, 3, 4, okay? And so let's say we're trying to get the leftmost digit here. So this n is going to say the n original, which is 1, 2, 3, 4, divided by the power of 10 raised to I, where I is going to be digits minus 1. So here we have 4 digits, so digits minus 1 is 3, so this is going to be 1000. So if we're going to divide n original with 1000, that will become 1. And so we already get the 1. And then this part here, because our n was initialized to 0, this one will just not be accounted for. But in the next iteration, where I is going to be minus minus, so instead of having digits minus 1, which is 3, it's now going to be 2. So this n is now going to be equals to the n original, which is 1, 2, 3, 4, divided by the power 10 raised to I. This I now is 2, so this is going to be 100. So n original divided by 100 is going to be 12. So now we're going to have 12, but we're going to say minus the original n, which was 1, n times 10. So that's going to be 12 minus 10, which is going to give us 2. So there we get the second digit. And then this is going to work for the third and the fourth digit. So that's how it basically works. So we're just going to remove that. And then now that we got the leftmost digit, we're going to begin asking, is n equals to 1? If it's equals to 1, then we're going to be doing this thing. Else, then we're just going to be drawing the number. And then we're going to say x plus equals 10. Now, why exactly are we doing this for 1? Well, let me explain first why we're doing this for the rest of the numbers. So basically, our x starts on the leftmost. So we draw our first digit here in the leftmost, and then we change that x value plus 10. So we basically change the cursor of the next text. And then for 1, this is a special case, because if we look at the big numbers here, the sprite, if we look at 1, there is a gap here at the leftmost. Unlike the other digits, they don't have any gaps at the leftmost. So this gap here is 2. So we say minus 2, so then we can bring the draw to this part here, and then we say plus 6, because our digits here, remember, was 1, 2, 3, 4, 5, 6. That is the reason why we say minus 2 plus 8. 8 because that's minus 2 plus the 6, so that becomes 8. And so we already have this draw score. And we're just going to basically grab this and replace this point system with draw score. And we're just going to put in here PTS. And then we're going to move this. And that's going to start drawing our score like so. You could see it's right there. There we go. By the way, the y is equal to 40. I forgot to mention that. There we go. So we could see it's working for the first digits. And then once we add the second digit, it should also work. There we go. We have 10, and then 11 is a special case. Then 12, it becomes like that. So you could see it's working exactly the way we want it to look. And it's starting to really look like Flappy Bird already. At this stage, it already looks like Flappy Bird until we die, and then we see no menu coming out. So the next part is the menu. Just for the lols, let's say that our score starts at some big number. Let's say it starts at 1, let's say like that number. And if we are going to run this game, you would see that we have that very big number printed right there. So our script works for very large numbers. So if your score goes that high, it will still work. So before we can make the menu, let us remember how the menu looks like. So here we have the finished product of the faithful remake of Flappy Bird, which I've made before. And if I were to die, you would see these things appear. So we have the game over that jumps in and out. And then we have the medal that swoops in. And then we have these buttons that appear. So first things first, let us change these points back to 0 as it's supposed to be. And then let's go to our room and see where we are supposed to be putting our menu. So the game over will appear, I think it will be somewhere here. Score will appear this area here. And then for the buttons, well, we're going to be handling that in another time. But for now, we're just going to be looking at the game over and the medal. And we could see that they are at position 72, 80, and 72, 128. So we're just going to be going to the object bird and we're just going to go to the draw event, and we're just going to be pasting this. So basically we're just drawing the game over and score at their positions, and because we're drawing it already there, if we go back to the room and just delete these two, it should still be printing out because we're drawing it right there. But we don't want it to be always there. This is just for temporary. So we come back to the draw. Let's just comment out this score because we just want to handle the game over first. So we want it to be at 80 at the very end, but remember that the game over is jumping up and down. To do this, we're just going to be doing exactly the same thing as we did with the Flappy Bird as it jumps. We're going to be giving it a Y, and we're going to give it a speed. So we're going to say game over as stated as go, and we're going to say go Y is going to be equals to, let's say, 80 because that's where it is, and then we're going to say go SPD is going to be equals to, let's say, -1. Our go SPD in the draw event, we say go Y is going to be equals plus equals to go SPD, like so, and we just copy this and put this here. If we were to run the game, we would see it's going to just jump up and just keep on going up. So we need to be changing this go SPD with some acceleration. So this go SPD is going to say go SPD is going to be plus equals to 0.01. And so it's going to go up and it's going to go down like so. Obviously that's a little bit too slow, so we're just going to say 0.1. It looks pretty right. But then we're also going to give it a maximum. So we're going to say minimum, and we're going to say 4 plus 0.1, and we just change this to an equal sign. There we go. And then here in the go SPD, we want to make sure that this Y, the maximum or the minimum rather, so the same thing, of plus go Y 80, and this, it's there. We see the game over is jumping and it's staying right there in that position. So the next task is that we want to be drawing that game over at a particular time, particularly when we die, and we just wait for a couple of frames and then it's going to jump up and down. So to do that, we're going to be adding a timer. So we're going to be saying we're going to have a go timer. So we say go timer TMR is going to be equal to 0, and then we go to the scripts, and in the bird scripts, when we are in the dying phase or the dead state, we are going to be saying go TMR plus plus, and then make sure that when we die, we make the go TMR equal to 0. So it restarts to 0, and then when we're in the dead state, it goes plus plus. And then once we say we go back to our object bird in the drawing, and so we ask ourselves in the draw if state is going to be equals to dead state, and the go timer is let's say greater than 7. We're going to be drawing all these. So if we run the game right now, we don't see it, but once we die, it should appear. So let's say we make this a little bit longer. Let's say we add let's say 30. There we go. So when we die, in 30 seconds it appears. Oop. Or 30 frames rather. Now we want to be adding the score after 30 seconds. So we're just going to be going to this one here. We're just going to uncomment this one, and then instead of just drawing it here, just going to grab this. So we're going to put an if statement here. Boom. We're going to put another if statement. If go TMR is greater than, let's say, 70, or let's say 60, then we're going to be drawing this sprite here. So we die, game over, medal. Now again, this medal should be swooping in and not just appearing like that. So we're going to be drawing this score, but we're going to make it first start below the screen, and then it's going to swoop up. So this 128 should be somewhere a value that's a lot bigger. So we go into the create, and we're going to be adding score Y. So score Y is going to be equals to, let's say, if we are going to go to the room and we're going to be adding the score, and we put it somewhere, let's say down here, this will be at 288, so we can just delete that. So that's for reference. So we say score is going to be 288, like so, and then we're just going to be copying this, and we're going to go to the bird scripts, and we're going to make sure that when we initialize the die, that our go score Y is going to be at 288, and then when we are here in the draw event, this thing should start increasing. So this is going to be score y, and this score y is going to be changing here equals to the maximum of 128 or score y minus 1. Let's say minus 1 for now. Just see how fast it's going to go. So when we die, we see the game over, and then that thing will just going to start swooping up. Now, notice how it's just moving linearly. We want it to move like very fast, and it's going to slow down as it goes closer and closer to its destination. The way I like doing smooth transition is that we're just going to be removing this. Then you're going to say minus equals because we're going upwards. And then we're going to say score y minus the destination, which is 128. And we're just going to be grabbing this. And then we're just going to be multiplying it with a certain value. Let's say 0.5. So this value here will start decreasing because this difference between score y and negative 128 is going to be lesser and lesser. So if we run this, we would see that if we die, it's really fast. So we need to be decreasing this, like let's say to 0.01. And that one's a bit too slow. So we're going to be going in between. So let's say, and I feel like it's around 1.5. Yeah, that seems right. So next thing we're going to do is we're going to be writing the score and the high score here in this menu. So just like what we did with the draw score, we're also going to make a new function to draw those numbers. So we're just going to say draw number, and we're going to have this function here. So I've already made it. So basically, we're using a do until loop. This is like a while loop, but we always will run this one time. Unlike the while loop, if we don't meet the conditions, we won't run it anymore. And then after we run this, we ask ourselves, did we reach this condition? If we reach this condition, we end the loop. Now, the reason why we're using a do until instead of a while is because we want to be running this at least one time. And that is in the case when the n is 0. In fact, if you recall, we actually had to do something like that. We had to have an edge case when n is equal to 0. And if we convert this to a do until, we can actually remove this edge case. So I'm just going to do that. And then we're going to call this a do, and then we put until. We're just going to put this here. It's exactly the same thing. We got the score still printing out at 0. And then it's going up at 1, 2, 3. So it's basically the same thing. Now going back to draw number function, the reason why it's a lot simpler than this draw score function is because we're drawing these smaller numbers, these numbers. And fortunately, if you were to look at the original Flappy Bird, it doesn't really care about the spacing. So even though 1 is smaller than 0 or 2, it's still going to draw it with the same space. Now we go back, and basically what this line is doing is that it's trying to get the first digit of n by doing modulo 10. And then it's going to print that digit, and then it's going to say x minus 8. Another reason why this one is easier to do is because we are drawing this starting from the right side. So we're drawing the first digit on the right side, and we're just going to continue on there. So we know that this right side is always going to be drawn here. It's never going to move. And then the other digits from the left are the ones that start increasing. And because it's going through from right to left, it's a lot easier to just do it in one loop. So that's basically what's happening. We're incrementing or decrementing the x, so then it's going to the left, and then we have this n value here that's going to change or remove the first digit. And then we're going to look at the next digit in the next iteration, and we're going to look at the next digit in the next iteration, and so on and so forth until we run out of digits, which is why we say n is less than or equal to 0. Once it's 0, then we end the for loop or the do until loop, and then that's it. So now that we have this function, we're going to be using this function to draw our digits. So we see that it has n, x, y, n being the number, and then x, y being the coordinate position. So here in this if go TMR is greater than 60, this is where we're going to be drawing our numbers. So we're going to be putting two of these guys here. So this one's basically draw number for the show points and for the max point. So currently these two variables have not yet been declared. So we need to be declaring that in the create. So just go to the create here. Show points is going to be equals to 0. And then the max point is going to be, well, we can set it to anything. Let's just set it to 100 for now. So this is actually your high score, and this is the current point that you got after you died. Now that we have this is our X positions are going to be 112. I've already calculated this. And then for the go score Y, well, I made a mistake. It's actually just supposed to be score Y. So we just change that. So this is the Y coordinate of your SPR score, which we're drawing. And the reason why we have score Y minus 11 and score Y plus 9 is because we are drawing these numbers relative to this sprite here, but we need to give it some offset based on where its position is on the score. So if we were to go to this SPR score, we would see that the origin is here at the middle center, which means that if we want to be drawing the score, we would need to offset it some pixels above it. And for the high score, we need to offset some pixels below it. And therefore, if we go to object bird, we would see that it's minus 11, meaning it's 11 pixels above, and plus 9 for the max points, which is 9 pixels below. So I've already calculated this already beforehand. And the way it's going to look like is when we die, you would see that the points will go with the score, right? Like so. So you might be wondering, why are we printing show points when we should be printing out PTS or points? Well, the reason is because show points and PTS are not exactly the same. You see, when the score appears on the screen, it will start at 0 and then it will start building up until it reaches points. So we're going to be making a new variable and we're going to call this PTS percentage, and this is going to be equal to 0. And then we're just going to make sure that when we go to our bird scripts and when we start the death, which is at die, we set this to 0. Now this is going to be incrementing when the go TMR is greater than 60. That's when it starts incrementing. So we're just going to say this points per is going to be equals to the minimum of 1, and then we're going to make this PTS per plus 0.01. So we're going to be incrementing it until it reaches 1, and then we're going to be saying that show point is going to be equals to PTS times this points percentage. And let's say we try to get as much points as possible. Okay, that's enough. There we go. You see, it's actually incrementing all the way. But I think that's a little bit too slow. So we're going to change this. I think we can change this to maybe like 3 times the speed. And let's try to die a little bit sooner. 7's a good number. There we go. And so you could see that it's incrementing, but I think it's incrementing a little bit too soon. So what we're going to be doing is that instead of doing this when go TMR is 60, we are going to make another one, but says go TMR is going to be like, let's say 70. And then we're going to be just grabbing this and putting it here. So it only starts incrementing when it's at 70. So let's just do this again. Okay, we're just going to die there. So there you go. You'd see that it started a little bit later and then it started scoring up. One suggestion that I could make instead of, trying to always play the game is that you just go to PTS here and let's say just put some points. Let's say we put 50 points already there. So when we start off, we already have 50 points. And so when we die, we will already be able to see how the points will add up. And I think it might be a little bit too soon. So that's why we can make it like, let's say 75. So let's just estimate. So we show and then we go. Maybe might be a little bit too soon. Maybe let's say 85. 85 sounds like a good number. And so we die. There we go. So we're able to see that the 0 appears right there and then it starts adding up. There we go. Yeah, that looks good. Now one thing you still can observe is that the points still remain up there. And what we want to do is that we want it to disappear when it's game over, when the game over appears. So that doesn't necessarily mean when we're at dead state, but it means when this go TMR is greater than 30. So that's relatively simple to do. Go and copy this and put it here. And then instead of greater than, say less than or equals to 30. And that should basically draw the points only when... That's it. Simple as that. Okay, let's move on. So now we want to be drawing the medal. Now, the medal is empty when we're less than 10 points. Once we reach 10 points, we get the first medal, and then 20 points reaches the second medal, 30 points reaches the next, and then the last one is 40 medals. So to do that, we're going to be asking ourselves, is PTS per already 1? Let's just say greater or equals to 1. And then I'll be pasting this draw sprite here. So this one looks a bit complicated, especially this part, which is the sub image. This is the X and the Y, and this is the Y coordinate. So the Y coordinate is just like what we did here with draw number. It's relative to the score Y. Plus 4 is the offset. And then for this sub image, well, this is a little bit confusing, but we're basically taking the minimum of this points divided by 10 minus 1 or 3. 3 is because we're trying to cap it so then it never goes beyond 3. That's because our medal has 4 sub images, 0, 1, 2, 3, where 3 is the last one, so we shouldn't go beyond 3. Next is explaining what this points divided by 10 minus 1 means. So remember that every medal we get is every time we reach 10, 20, 30, and 40, where 10 is the first medal. So that means that when we get the points and then we do integer division divided by 10, so that should, if we're 10, that should give us 1, minus 1, that should give us 0, so that's subimage 0. If we are 20, that will be 20 divided by 10, that will become 2, minus 1, that will become 1. And then let's say we're like 35, so let's say we're in a weird number. So 35 integer division 10, that will becomes 3.5, but because it's just integer division, the 0.5 gets removed, so that's 3, minus 1, that becomes 2. So essentially, this equation here, when our points is from 10 to 19, it should be equals to 0. When our points is from 20 to 29, it should equals to 1, and so on and so forth. Now, there is an edge case, and that is if our points is from 0 to 9. Well, if it's from 0 to 9, it will still print this thing out. So we have to make sure that our points is greater than or equals to 10, or else it will start printing it out. So we just grab this. And so if we run this, we would see that we have now score 50. When we die, the game over comes out, and then our medal will only appear when the score reaches 50. So let's just change our score to, let's say, 9, and this should not print any medal. So game over, 9, and there's no medal appearing. Let's bring that to, let's say, 10. So 10, there should be already a medal. Boom. Game over, 10, the medal's there. Let's bring it like, let's say, 17. If it's 17, it should still be the same medal, the bronze medal. There we go. Let's say we bring it to 26. That should give us the silver medal. There we go. And let's say we bring it to, let's say, 39. That should bring us to the gold medal. There we go. And 41 should give us the platinum. And if we like make it a very big number, it should still give us the platinum. There we go. So we've made ourselves our medal, but it looks very dull. And that's because it's missing those sparkling effects. And we need that to make our medal look more fancy. So here in the object bird crate, we're just going to be adding the X and Y coordinates of our sparkle, like so. So we're just going to be pasting this thing here. So SPX, SPY is the sparkle X and Y coordinate. And because that sparkle will be going around the medal, we're just going to be giving it a random range from 20 to 45 for the X coordinate and 1 to 2, 3 and 133 for the Y. And then in the draw event, we're just going to be drawing the sparkle. So just say draw sprite, and we're going to say SPR sparkle. And we're going to be giving the image of, let's say, for now, we're just going to give it 3. And then the X and Y will be the SPX and the SPY. We should see that there's a sparkle right there. But we want it to be flashing. We want it to be moving. So we're going to be adding another variable. And that variable is going to be called the SP index, which is the sprite index of the sparkle. And we're going to be first setting it to 0. And then in the draw event, we're just going to be saying that SP index is going to be plus equals to 0.2. And then we're going to be setting this sub image to that. There is a spark that happens, but it grows, then it dies immediately, then it grows and it dies immediately. And the reason for that is if we were to look at our sparkle here, we would see that it first starts at a blank and then it goes to this, then this. And then what happens is that because we are incrementing our subimage, it automatically brings it back to 0, which is empty, then like that. So it does this pattern here, which is not what we want. What we want is that once it from here, and it goes to this. We want it to reverse. So like that, reverse, like that, reverse. And so how do we do that? Well, we're going to be using absolute values and negative values. So to better explain this, I'm just going to be showing you the code. So we just go back to object bird, and then we're going to be saying if sp index is equals to 4, we are going to be reversing it by saying that sp index is now going to be equals to -3. So this will not really make sense right now, but if we were to say abs sp index, like so, you would see that now it's doing exactly what we're doing. It flashes, then it shrinks, then it flashes, then it shrinks. And if it doesn't really make sense, basically we go all the way 0.2, we go all the way to 4, and then once it goes to 4, we bring it to -3, and then this -3 would start incrementing back to 0, then goes back to 4, then goes to -3. So we go from -3 to 4, then -3 to 4. When it's from -3 to 0, we take the absolute value of that. So -3 absolute value is 3, absolute value of -2 is 2, and absolute value of -1 is 1. So it basically goes from 3 to 1, 0, and then 1, 2, 3. And then once it hits 4, it goes to -3, which will take the absolute value to 3, 2, 1, 0. So basically it's 3, 2, 1, 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 3. Now, we don't want it to be always flashing in the same position. As you could see here, it always flashes in the same position. So we want to be changing that sparkle position somewhere else. And we want to change it once it becomes 0. So if sp index is going to be equal to 0, then we just say, we go to the create, and then we're just going to grab this and paste it here. So we're just going to get another random value. Game over. There we go. So now it's going some random values everywhere, and we have some sparkling effect. Very nice. So we are now on our final stretch in making Flappy Bird. There are just a couple of things that we need to add. One of those are the buttons. So to make buttons, we might be thinking, well, we can make just another game object. But as you can see, we've been always just making everything in object bird. So we're going to be sticking to that. But how exactly do we make buttons that we can click without making an extra button? And that is through constructors. We are going to be making a constructor, which is simply like a class in other languages. So to do that, we are going to go to bird scripts, and we're going to go all the way down here. So we're just going to say function, and here we're going to say button with the parentheses, and then we're going to say constructor. So this is how you create a constructor. And here inside the constructor, we're first going to be adding some parameters. So we're going to add x and y. So this is the x and y coordinate of the button, but the button cannot save these values. So we have to save it by saying x is going to be equals to this x, and y is going to be equals to this y, because these guys here are only going to be temporary. These values are only going to be there when we initialize the button. So we need to save it into its own variable called x and y. And then we want to be drawing this button. So we're going to be making a static function for the button. So we say static, and we're going to say draw is going to be equals to a function. So this is how you declare a static function. Now, the reason why we're making it static is because we only want to be declaring this once. We don't want to be declaring this all the time, every time we make a new button. So anyways, here in this function, we're going to be saying draw sprite like usual. But in this draw sprite, we're going to be saying SPR. We're going to be stating that later. Some image is going to be equal to 0, and then x and y, like so. So this SPR has not yet been declared, so we're just going to be making a new variable called, SPR. This is temporary, so we need to store that temporary value here, like so. And then, now that we have our button, we can go to object bird, and we can go to the create event. And here, down here, we're just going to be saying that we're going to make a play button. It's going to be equals to a new button. This is how we declare an instance of a button. And then here in the x and y, we're going to be just saying 12 and 1, 7, 1. And the sprite is going to be equals to SPR play button. We're going to go to the draw event. And here in the draw event, right next to the sparkles, we're just going to say play button is dot draw. So when we die, we see game over, all the score, and then the button appears. So we want to be adding another button, which is the leader button on the right side. So how do you do that? Which is simply copy and paste this create of the play button, and then but instead of play button, we're going to say leader button, And we're just going to say, instead of this SPR play button, we're also going to change this to leader button. And then here, instead of 12.171, we're going to change this to 80.171. And we go to the draw event, and then here we're going to say leader button dot draw. That's it. And see that when we die, two buttons now appear. And now this has the leader button sprite, and this one has the play button sprite. But when we try to click these guys, nothing happens. So how do we fix that? So we'll be going back to our bird scripts, and we're going to be adding two more functions. These functions are going to be called button pressed and button release. Based on the name, basically button press is when you're on top of the button and you press that button, it's going to return true. Whereas button release is that if you're on top of the button and you release the button, that's when it will return true. So this button press is dictated by the mouse. So when we left click on the button, it returns true. So basically, just left clicking alone is not enough because we can left click any place in the screen. We need to check whether or not our mouse X or mouse Y, which is the coordinate of our mouse, is within this rectangle. So point in rectangle is the function that we're going to be using. So this X and Y is the X and Y of our button. And then we say X plus 52, Y plus 29. So we have this box position, X, Y, X plus 52, Y plus 29. And if our mouse is somewhere within this area and we have left click, this thing returns true. So for button release, it's exactly the same thing, except that instead of mouse check button, it's mouse check button released. So it's pretty simple how these things work. Now that we have these, we need to be changing how the sprite will look like when we are button pressing and when we button release. So we're just going to say here at Y, we're going to say plus button pressed. As simple as that. This will create this idea that when we die, when we click on the button, you see that it goes down. So and the reason is because when we say button press is true, it's going to be adding a +1 value here. So it's basically going to bring a +1, so it's going to make the Y coordinate of the sprite go down. And so what next is that when we do button release, that's when we are going to be doing a certain function. So let's say if button released, then we are going to be saying, let's say game restart. So when we click on the button, notice how it goes down when we are on top of the button. But if we release the button right here, it's going to restart the game. Right now, all buttons will game restart. We want to make sure that our buttons do a particular function that we set it to be. So instead of just doing game restart, we're going to be adding another function here in the parameters, and we're going to call this func. And then this func here, so we say func is going to be equals to this func. So like just the rest. And then this func is going to be what we're going to be running. So we say script execute. And here in the script execute, we're going to say func. That's so. Now this func, we need to be setting it in object bird. So we're just going to say, I don't know the parameter here. And we're just going to say game restart, just like the usual. And the one below, don't put the parameters. And then the one below, we're just going to say no script. So no script does not exist just yet, and what no script is going to be doing is practically nothing. So we're just going to say here function no script like so, and pretty much just do nothing. And when we click on the leaderboard, nothing happens. But when we click on this button, it goes and restarts. Now right now when we die, if we click on the play button right here, it will immediately reset the game. What we want to happen is that we want it to fade into darkness and then fade out again to the prep state. So how do we do that? Well, we'll just go down here, and instead of putting the if button released here in the draw function, we're going to be removing this, and we're going to be adding a new function that's called static, and instead in draw we're going to call this activate. And this function will be having this if button released inside. And then for us to use this activate function, we'll go back to object bird, and then in the draw event we're going to be saying play button dot activate. And then now we will try to create a black fade. So it's just going to be like the flash, but instead of flashing, we're going to make it see black. We're going to be using another variable that's called dim. So we go and create the dim function. We'll initialize it here. Dim is going to be equals to 0, and we say toDim is going to be equal to 0. So to dim is basically where we want to go. Do we want it to dim or do we want it not to dim? So if it's 0, it means we don't want it to dim. If it's 1, we want it to dim. And then we go to the step event, and we're just going to be copying this lin trans thing here for get ready. But instead of get ready, we're going to say dim is going to be equals to dim, and the state is going to be something else. So we're just going to say here to dim, and I made a mistake. We are supposed to be putting dim here to 1. So in the beginning, it's going to be dark, and then it's going to fade into 0 to dim. So if we're going to run the game, we'll see that it first starts at dark, like so, with the get ready. That's nice. But we want it to be a little bit different from the get ready. So we're just going to be changing the step event. Instead of 0.05, let's say we're going to make it 0.1. So it's going to be double the speed. There we go. So it's a little bit different. And when we click on this button, it should dim and then it should undim. So to do that, we're going to be creating another function called make dim. And this make dim, and then we're going to be saying object bird.toDim is going to be equals to 1. Now the reason why we're saying object bird is because this function here is going to be run by the button, not by object bird. There are two different things. So we need to state that it's object bird's toDim that we're making 1. So we go back to the object bird, and instead of this play button saying game restart, we're going to say make dim, like so. And then in the draw event, we're going to be saying if dim is equal to 0, then we do play button activate. Else, if dim is equal to 1, or rather greater than or equals to 1, game restart. So when we die, it should say game over, and then when we press this button, it should dim and then undim. But you've noticed that some of the stuff are still being seen when it dims, and that's because we drew the dim earlier than the stuff here, the sparkles and everything. So we need to be bringing all of this, the dim and the flash. Let's just bring the flash as well, all the way down here, and that should fix that. It should make the dim draw last. And so when we die, again, game over. When we click this, it should dim everything, and then it should get ready undim. Now we're almost done with our Flappy Bird. We just have to add a little few extra touches, and those are the sound effects in our menu. So the first one happens when go TMR is equals to 30. So we just say if go TMR is equals to 30. And then here we're just going to be saying audio play sound swooshing. And then we're just going to copy this and paste it here where it's equal to 60. So we just say 60 as well. And then we're just going to keep copying this. And then we go to bird scripts, and we're just going to be pasting it right here under make dim. And so once we run the game, we should see that it should be working. But it seems a little bit too fast. So we need to fix that. So what we're going to do is that we're going to go to object bird, and we're going to be changing the go TMR times. So we're going to make it a little bit longer. So we're going to say 30. I think 30 is fine. But here in the 60, we're going to be adding some extra 30 seconds here. So we're going to say 90 and 90 here. And then instead of 85, we're going to add another 30 seconds. So that's going to be equals to 125. So now if we play the game, it should get the right timings. But when we press this button here, the swooshing sound disappears immediately. And that's because when we game restart, everything gets restarted, including the sound. So we need to change the restart. So to do that, instead of just doing game restart, we're going to be removing this and actually just copy and paste entire everything here. Just copy and paste this thing here. So we're basically just restarting and then reinitializing everything. And then in the create, we also make sure that we copy this as well, the state, so we make sure it goes back to prep state. And then there are other two more things that we need to check, which is the sprite, the image speed, which is going to be equals to 1, because when we die, the image speed becomes 0. And then the last one also is going to say image angle, and this should be equals to 0 because we are facing downwards when we die. So if we run this, this should do exactly what we want. There we go, and we still hear the swooshing sound when we go back to the prep state. Very nice. Now there's still a few things we need to fix. One of them is the score. we want this to change as we get higher score, and we also want to make this back to 0. So we're just going to do that, and we're going to change this to 0. Now there's a problem that I've noticed, is that when we die, when our medals is not yet 10, it still has a sparkle. So we just have to, that's a very easy step. I made a mistake here. Instead of drawing it outside here, we just put this inside this point is greater than or equal to 10. And so only when it's greater than or equal to 10 do we actually add the sparkles. Now the next part is adding the high score. So to do that, we go back to high score. So instead of just saying max points equals to 100, we're going to be grabbing this and we're going to be changing it to look something like this. So what this does is that it's going to be loading a variable into max points from the data.ini file. So this data.ini file will be stored in the computer, and then what's it going to do is that we're going to be reading that data.ini file. We're going to be reading what's a score, which is a variable, and then if this doesn't exist, we're going to be setting it to default 0. And that's how we get max points. And then we're going to be just closing the file. Make sure you close the file. Now note that we have changed this max points here, but if you go to the draw event, we have this max point still back to this 100. So that means that by just copying and pasting, we have to be copying this again and pasting this here, which is not very good practice. So what we're going to do is that we're just going to be grabbing this. Oh, and make sure you grab this one first. So we're going to grab this, and then we're also going to be pasting it right here. Including this, I realized that we also need this one as well. So paste this here, remove this state because we already have it up here. And then we're just going to be grabbing all of these things, cut this, and we're going to be bringing it to its own function. We're going to be calling bird init. And in this bird init function, we're going to be pasting everything that we have made right here. There we go. And then make sure that we go back to our object bird and put it here. And also we're going to be putting this in the draw event here as well. So we're going to be grabbing all of this, removing it, and we're going to be pasting the bird init. So we're going to be initializing it once. And then once we've done that, let's go back to the bird scripts. We're going to be copying this, and then we're going to be setting our score right here when we are done displaying the score. So here, when the play button, leader button is being drawn, we also going to be setting our score right here. But however, we only set the score if our score is greater than the max point. So we say if PTS is greater than max points, that's when we're only going to be setting our score, because we don't want it to change the score if it's less than the max points. So we just put it here, and then instead of saying max points ini real, we're going to be removing this max points here, and we're going to set this to write. So we're going to write real to var score, and then we're going to be setting it to PDS, which is our new max points. And then we're going to also say max points is going to be equal to PDS, or else it won't change. And then if you run the game, it should work exactly the way we want it. We would see that when we die, when we have a score of 0, it will still remain 0. And then if we restart the game, and we go all the way, and let's just say we get the 1 point, there we go, we'll die. It will still say 0, but once the score becomes 1, it will say 1. And if we die right now, it will still remain as 1. If I were to close the game and play the game again, and we die, it should still say 1, which is very good. So let's try to get a higher score of, let's say, 2. So we reach 1, 2, and let's just die here. We would see that the score is 1, and then it changes to 2 once we get the high score. Now, one of the things that we want to add is that once we get the high score, it should say new best. Right now, it just say best. So we're going to be adding the words new, which is going to be a sprite before best. To fix that, that's relatively easy. All you have to do is just go to this part here, points is greater than the max points, and just add this draw sprite, which is SPR new, which is this sprite here, new. And we're going to be drawing it right before the score, which is I already calculated the distance, which is this one, 83 score y plus 1. It's a 1, 2, 3, and then the new score should appear, but it disappeared immediately. Well, why is that? The problem is that once we set this max points equals points, this guy here is not anymore true. Therefore, we can't do this. We have to say a new variable, which is going to be, say, new score. It's going to be equals to 1. And then we say if new score, then we draw the sprite. Now, this new score is going to be part of our bird scripts here. And we're going to be setting this new score to 0. like so. So this guy is going to turn 1 once we reach a new score, but it's initially 0. So if we die right now, it should say nothing, no new best. But let's say we try to get a new score of 4. There we go, and let's just die here. It should say 1, 2, 3, 4, and boom, and then it says new best. There we go. So basically that's it. We've got ourselves a working Flappy Bird that looks and feels exactly like Flappy Bird. Amazing. So we see here, it works exactly the same. We can get whatever score we want. We can go 3, 4, 5. Very nice. So we do this, and let's just say die. Game over. The score 6, new best. We want to get a medal. Let's go and reach 10. Let's go. 13, let's go. Game over. Score. Boom, boom, boom. Medal. Blings. New best. 13. We die here. It will say is game over. 0. Best 13. Let's try to get something less than 13. Let's just say we get 1. Boom. Die. Game over. Sounds 0, 1. Best. No new best. It's still 13. No medal. Everything works. The only thing that doesn't work yet is this little button here. And the way to fix that is we just go all the way back to our bird scripts, and we just go to the no script, which is what we're using. And instead of just having nothing in the no script, we just put this open URL to this YouTube channel right here. This is going to open it, and it's going to make you subscribe to my channel. Please do like and subscribe if that's the case. Anyways, I hope you guys enjoyed this Flappy Bird tutorial. I will be making more tutorials in the future. Hope to see you guys next time.